一
Hello, everyone. Our final project topic is fetal health classification, and our group members are Yu Cao and Jing Shanwan. Next page, please. So our presentation is divided into 6 parts, and I will present for the first 3 parts: introduction, descriptive analysis and validation, data processing, and my teammates Yu Cao gonna do the rest 3 part, model fitting, conclusion and limitation. So the first part of our presentation is introduction. So first, I will talk about something about our the background of our topic. So the reduction of the child mortality is a very important index. So this topic is very meaningful and important because we can see fetus health is very important. Children is the future of our society, and that's the reason why we build a lot of like the universities to make the children get a healthy get education, to make them grow up healthily, and so they could make some like contributions to give back to our society. And CTG is a simple and cost accessible equipment to access fetal health. So this equipment could collect some data of the fetus, and they allow the healthcare professionals to take some countermeasures to prevent the child mortality. So the purpose of our project is use different algorithms to establish models to classify the health of the fetus by analyzing the data collected by this equipment. Next page, please. So actually in the real life, when we're trying to do the prediction or the classification of the fetal health, there could be 2 types of error we could make. So the first one is like there is a fetus which is actually healthy, but the predictions in case unhealthy. So avoiding this type of error could effectively save some medical resources, especially in some developing countries. The resources are very limited. So if you made some mistakes like this type mistakes, it means like some fetus who is really unhealthy will lose the chance to get the medical resources. And the second type of the error is even more serious. So that is fetus which is actually unhealthy, but the prediction thinks he's healthy. So avoiding this type of error can greatly improve the fetal survival rate. So the purpose of our project is trying to improve the accuracy of the models and trying to avoid these 2 types of errors. Next page, please. So our data set is released by someone in Kaggle, and there are more than 2,000 observations in our data set, and we also have 22 different fetal health related variables. Especially the target variable fetal health. This is a category variable with value 1 means normal, value 2 representing suspect, and value 3 which is pathological. So this is a table which shows the rest of variables, which is also the independent variable we might use in the following modeling part. Yeah. Next page, please. So the second part of our presentation is going to be the descriptive analysis and the validation. So the first chart is a pie chart which shows the population of the fetus under 3 different categories. So we could say like the fetus like with a normal health condition has the highest population, reaching almost 90%, and followed by the fetus with suspect health condition, accounting for 26%, and the population of fetus with pathological conditions is the least, which is only 4%. So this pie chart actually gave our some ideas in the following steps we should considering using the stratified sampling method to build the training site and test site. And the next chart is a histogram chart, which is about the variables theta health accelerations under the three different categories. So from this histogram chart, we can see like the variable um, of normal thetas, the value is significantly higher than the other two. So it shows the variable accelerations is very valuable in distinguishing whether the theta health condition is normal or not. Next page, please. So the third chart is also a histogram chart, which is about the fatal movement under three different groups, very similar as a previous one. So the variable theta movement, we can see the value of pathological thetas is significantly higher than the other two, which shows this variable is very valuable in classifying whether the theta health condition is pathological. So the next histogram chart, we could see there is a three variable we used here. They are all about histogram. They are histogram medium, histogram mean, and mode. So we could say like actually the differences of these three variables under the three different groups are not very big. Only the value of the fetus whose healthy condition is pathological is slightly lower. But what I want to talk about here is actually there is almost no differences between these three variables under the same classification. So actually, we could considering removing these three variables and trying to replace them with a new variable. Maybe we could consider using the average value of these three variables. Yeah. Next page, please. So the last chart of our validation part is about the histogram tendency, this variable. So we could say the value of the pathological fetus is obviously different from the other two. It's even negative. So it actually shows this variable histogram tendency. It could be very useful and valuable in our following modeling part. So the third part of our presentation is data processing. This is a correlation map we get in our Python code. So so the first thing we do the data processing is check and remove the missing values and outliers in our data set. We have already done it before the validation part. And the second one is correct the data types, which is very helpful in the following steps. By the way, like we will also do some little adjustments of the data types according to the specific the models we choose. The third part is like we mentioned before. Also, we can see in the correlation map, there are three variables, which is a histogram medium, histogram mode, and histogram mean. There are very strong correlations a relationship between these three variables, so we could actually remove these three variables and replace them with a new variable called histogram 3M, calculated by the average of them. So let's welcome my teammates Yucao to do the rest part of our presentation.
Hello everyone, this is Yucao, and I'm gonna introduce the rest of our project. And here's the four-part, the modeling fitting part. So the Jingshan one said, as the Jingshan one said before, the feature selection is our first method to improve our model, and our second method is to use the stratified sampling because our our target variable are not even. There are significant different data have the significant different data size observations. So after we use the stratified sampling method, we notice that it has a significant increase our modeling accuracy, and also we use the cross validation to improve the which can also has a slightly increase of our data modeling fitting. And the first of our model is random forest. So this model is very very easy to interpret, pretend, and easy to understand. So in this model, our final accuracy after all the processing, our final accuracy is 91.34%. And here we move to the neural network. Before we move into the rest of the models, we need to change our target variable into two categories, because in the Python Spark environment, we use the machine learning classification library, which can only support binomial classification. So we need to change the our target variable suspect and pathological, and merge them and rename it as 1, and change the normal one and rename it as 0. So we have two types: it's normal and unnormal. So in the neural network, our and we we also did the stratified sampling and the cross validation, and our final accuracy is 88.50%. And in the logistic regression, we have the highest accuracy, which is 91.59%. And also logistic regression is also relatively easier to understand and interpret. And in the SVM modeling fitting, we changed some metrics, which is regression to choose the best model. So after we did a comparison, the regression equal to 0.1 has the highest accuracy, which is 90.53 final accuracy on SVM model. So here's a next we move to the conclusion part. So here's the total accuracy, the accuracy table. So as we can see, logistic regression and random forest are highest two model, and also logistic regression has very good performance on binomial classification, and it has the highest accuracy score above around among our models. And so we want to use a logistic regression to do the model to do the prediction first, so which can predict this fetal is normal or unnormal. Then we can use the random forest to predict that the unnormal fetals are suspect or pathological. So here's we move to the limitation part. So what we have done in the random forest is multivariation classification, and what we done in the other models is binomial classification. So this makes some deviation when we make the comparison among this all of our models, because there are target variable different types, 3 types and 2 types. And also another limitation is our target data volume is not very large. So the effect of our model has not been particularly well tested. So if we have the larger data in the future, so we might do our process again, and we can get a better and more practical model to predict the fetals healthy or not. And thank you, everyone. Here's our project of the fetal health classification.